I kind of chopped it up into two sections. First, I'm just going to talk about similar triangles and how they work. So, similar means there's the same angles, but not the same sides. So, they're the same shape, but not the same size. These are different ways of saying similar. The most important thing to remember is that similar triangles, the angles are congruent, but the sides are proportional. And that means you can make ratios out of the sides, which is going to come in handy when there's a missing side. We can create a ratio and solve for it, which you all are so amazing at. So let's take a look at this. By now, you should know that tick marks show congruency. So every time you see a little tick mark, that means those are congruent. So with these two triangles, A has one tick mark and Z has one tick mark. So that means they are congruent. They're the same angle. B has two tick marks and Y has two tick marks. So they go together. They're congruent. Now you see how X and C don't have anything? But I want you to think all angles in a triangle add up to 180. So if you know two angles are the same, you know that last one is going to be the same too, because both of those triangles, the angles have to add up to 180. So they're going to have that third angle be the same every single time. So as long as you know that two angles are the same, you know that third one is the same. So it tells you that those triangles are similar. You can tell by looking at them they're not the exact same size. It's better in the book. But they're not the exact same size, but they are similar because they have the same angles. So the corresponding angles, that means they're in the same spot. The angles are in the same spot. So A and Z, you see how they're in the same spot of the triangle? B and Y, they're in the same spot. And then C and X. So this little symbol means congruent. It's like an equal sign with a mustache on top of it. So that means A is congruent to Z, B is congruent to Y, and C is congruent to X. Now over here, we know the sides are not congruent because they're not the same. But it's just showing that the corresponding sides, AB is corresponding with ZY. You see how they went the same direction when they named it? A to B, Z to Y. They didn't say Y, Z. That's important. And then BC and YX. And CA and X and Z. So they went this way. CA, X, Z. Those are corresponding sides. The corresponding sides can create ratios because they're proportionate. And I want to show you in this triangle, they gave all the sides. Triangle A and triangle B. You see that there's two angles that are the same. And of course that third angle, it doesn't say it, but you can kind of tell it's 90 degrees. So right triangles, right? So all three angles are the same, or they correspond with each other. They're congruent. So we know that the sides are going to form ratios. And this is how we can check. So I went triangle A over triangle B. That's the ratio I'm creating. So I chose a side, 6, that's triangle A. Doesn't 3 correspond with 6? So that's my first ratio. And doesn't that ratio reduce to 2 over 1? Okay? And then I did the same thing with the next side, 8 and 4, 8 over 4, and that also reduces to 2 over 1. And then 10 and 5, 10 over 5, that also reduces to 2 over 1. So in this little triangle, these triangles, it shows you these are proportionate because the ratios all reduce to the same thing. Okay? So really, isn't this triangle just twice as big as this one? 3 times 2 is 6, 5 times 2 is 10, 4 times 2 is 8. Okay, so that's a scale factor, but that's another story. Right now, we're just showing that these are proportionate. So if we find a triangle, or we see two triangles, and the angles are the same, but we're missing a side, we can use this, set them equal to each other, and cross multiply like we're so used to doing. So that's the next example. I'm just going to draw this really quickly. And if it's not good, I'm sorry. I really am. So it's 3, 5, and 6. And then the other one is A and 10. They don't even give you this side, which is crazy. But they're asking for the measure of A. And of course, they have angles that are the same. If you're looking in your book, they have like this angle and this angle and this angle and this angle. Okay, I didn't want to draw it all, but you can tell they're similar because they're going to have all three angles the same. The sides are not the same, but the sides are proportionate. So I'm going to start with this triangle first, and then I'm going to go to this triangle. You're going to use two sides that you know. What side corresponds with 6? Well, that would be 10, okay? So I can write a ratio 6 and 10. Start with the same triangle, 6 and 10. Now, do they want to know this side? No, so we don't even really need that 5, right? I'm just going to use 3 and A because we're looking for A. So you want corresponding sides that you know both of them, and then you want the corresponding sides that have a variable. So we're setting up a proportion, or a ratio, proportion, sorry, I was going to say proportionate. We're setting up a proportion. That's when you put two ratios equal to each other so you can solve for something, which you've been doing all the time. So we started with 6 first, so we're going to stay with the same triangle and put that triangle on top, and then A corresponds with it. Now that you have this, it's super easy to just cross multiply. So 6A, 6 times A equals 10 times 3, which is 30. And if you solve for A by dividing by 6, A equals 5. Okay? So we have 5, 3, 10, 6, and then of course we could solve for this side if we wanted to by setting up another ratio, but I don't feel like it because we don't have to. So that's all there is for the similar triangles. I'm going to have to come back and do indirect measurement because we use this principle to find lengths of objects that are kind of tall and we can't measure them. So I'll do that later, but right now I just wanted to introduce you to this. So hopefully this helps, and let me know if you need any help. So I'm completing the lesson about the indirect measurement, which goes with similar triangles. So remember, the similar triangles said that if the angles were the same, the sides are proportionate and we can create ratios. So we're going to do that only with real life situations where we can't really measure something, but we can kind of guess based on indirect measurements. I want you to think about when the sun is shining. Remember, you know how sometimes your shadow is a little bit longer than other times because the sun's at a different angle? Okay, so if the sun is shining at one place, it's going to be creating the same angle for every person in that same location. Okay, so this is the idea that Beth is standing here and a tree is standing in the same area at the same time. So they're creating a 90-degree angle with the ground, right? The height is creating a 90-degree angle with the ground. And the sun is creating the same angle with their shadow because it's at the same angle. Okay, so we know that 2 of these angles are the same, so we can assume the third one is the same, and we can pretend that not pretend anything, these are similar triangles that are created here. So this line is the shadow, this is the height, and this is just like an imaginary hypotenuse. We don't need it for anything, it's just kind of there to show that it's a triangle. Here's her shadow, here's her height, and there's, once again, we're just showing that it's a triangle. You don't even have to draw the hypotenuse. Okay, so the sun creates the same angles on them, and there's a 90-degree angle, so we can assume these are similar triangles, and we can use the ratios to find the height of the tree, because I can't just measure the tree real quick. It's pretty tall, right? So I need to be able to indirectly measure it. So here we go. I created the tree to Beth. It said that Beth was 5 feet tall, her shadow was 6 feet. And the shadow was 30 feet, we don't know how tall it is. So I decided tree Beth. So height over height, right? We don't know the height of the tree, we do know the height of Beth. And then shadow and shadow. Make sure you have the same thing on top and the same thing on bottom, like I've mentioned, tree over Beth. Okay, and then we can do our cross multiplication. 6x equals 150. And when we divide by 6, we find out that the tree is 25 feet tall. And doesn't that make sense, right? Because she's 5 feet and her shadow is 6 feet. So her shadow is taller than she was. The tree is 25 feet and the shadow is 30 feet. And the shadow is longer than the tree is tall. So the whole idea here is that we can use similar triangles. We can create the triangles in order to find the height. Oh, where's my eraser? I'll be right back. Example 2 is referring to a pole, like a flagpole, I think, and then a meter stick. So a meter stick is 100 centimeters. all right? So I'm just gonna draw this really quickly. See, this is what I do. It doesn't even have to be a tree and a person. I just kind of draw lines to show that it's a triangle. So here's the pole, and I think the shadow was 24 feet. Okay? And we don't know how tall that pole is. And I'll draw the little just to show us a triangle. And then the meter stick is 100 centimeters. And the shadow is 40 centimeters. So this is obviously at a different time of day because the shadow is shorter than the height, right? So shouldn't the height be bigger than the shadow this time? Because if it's 140, it's going to be bigger than 24 over here. So just think of those things. Now, you do not have to change these to centimeters and feet. You don't have to change the units because we're using numbers here to try to find it. Like, we're not mixing them together. It's a ratio, so it's a little bit different. Let me show you how it works. I'm going to say pole over meter stick. Okay, I'm going to start with X feet over 100 centimeters. And I'm going to show you how all of these cancel, like when we do unit multipliers, to show you that the units are not changing anything if we keep them the same thing. And then we have 24 feet over 40 centimeters. Okay? And I don't need the feet there. So I'm going to cross multiply X times 40 centimeters equals 100 centimeters times 24 feet. I hope I'm still in the shot over here. Okay, so we have to divide by 40 centimeters to find X, right? It cancels. I want you to see what happens to the centimeters over here. They cancel. Okay, so you're just left with feet when you're done. So when you multiply 100 times 24, you get 2400. Sorry, I'm going to come over here. And then over 40. And you end up with 60, wait, hold on. Yeah, 60 feet. Now, this was to show you that they all cancel. You don't have to put all of the things, just use the numbers. I'm just showing you, you don't have to change feet to centimeters and centimeters to feet in order to do this. So you can just do X over 100 equals 24 over 40. Oops. You don't have to put all the units in there. I was just showing you that they cancel. Okay, so no need to change feet to centimeters, all that crazy stuff. Just use the numbers and your answer, if you do it correctly, will be 60 feet. And that's it. Example 3 is a little bit more dramatic. Like, they're trying to make it more difficult to see if you can use your reading comprehension skills, which you all have. I know you do. So here we go. Brad saw his shadow was about 3 feet. So here's Brad. His shadow was 3 feet. I'm guessing he's taller than 3 feet. That's why I drew it a little taller, right? The shadow of the flagpole, he decided that his shadow was 1 big step. So 1 big step is 3 feet. Okay, that was in the book. The shadow of the flagpole was 8 big steps. So if 1 big step is 3 feet, 8 times 3 is 24. That's basically the only, I don't want to say difficult, but you're going to have to figure that out yourself. I'm not even going to draw the hypotenuse here because we already have what we need, basically. Brad is 5 feet tall. So, Brad over flagpole. 5 over X equals 3 over 24. Make sure you're doing, the height together and the shadows together too. So 5 times 24 equals 3 times X. Okay, we end up with 120 equals 3X, divide by 3, divide by 3, and X equals 40 feet. So that flagpole is 40 feet tall. There was 0 way I'm going to be able to measure that by hand with a yardstick, with a tape measure, anything. So using indirect measure helps with that. And that's all about similar triangles. The shadows are going to be the same angle, or the sun's going to hit you at the same angle, and you're going to be 90 degrees with the ground. If you're on a hill, it's going to be a little bit different, but we're just talking about regular stuff here. So that's it. If you have questions, let me know.